Easter Island, or as it's called in its local Polynesian language, Rapa Nui, is famous for its 887 giant statues called moai. No one knows exactly why or how the statues were created, and much of the island's past is shrouded in mystery. You might be asking, what in the world does Easter Island have to do with longevity science? It turns out, quite a lot. A special discovery at Easter Island is our current best weapon in the fight against aging and age-related disease. Scientists became interested in the island due to its strange lack of tetanus infection. Tetanus is an infection caused by bacteria often found in animal waste, and it's common wherever barefoot human populations live near livestock like horses. Easter Island is just such a place, with horse populations and barefoot human populations living in proximity to one another. Tetanus should be a huge problem. This riddle was too intriguing for scientists to ignore, and an expedition set off for the island in 1964, led by microbiologist Georges Nogrady. Scientists collected soil samples and returned them to England for further study. Unfortunately, Nogrady didn't find anything particularly interesting in the soil, other than a strange lack of tetanus bacteria. So he gave the soil to Ayerst Pharmaceuticals, now Pfizer, for further study. What the pharmaceutical team found was shocking. A special type of bacteria in the soil called Streptomyces hygroscopicus released an antimicrobial compound which protected the island's human inhabitants. This compound was named rapamycin, Rapa after the island's name, Rapa Nui, added to mycin, a common pharmaceutical suffix for antimicrobial agents. For example, gentamicin, azithromycin, and erythromycin. The team originally wanted to market the drug as an antifungal, but one Ayer's team member felt the drug had much more potential. She discovered that it had immunosuppressive effects, and her discovery led to the drug being marketed to prevent organ transplant rejection and treat some cancers. Still, she felt like the drug could offer more than just immunosuppression. Over the decades since its discovery, multiple independent teams have confirmed her beliefs and found that rapamycin targets and inhibits a specific aging pathway, now called the mTOR signaling pathway, short for the mammalian target of rapamycin signaling pathway. It does so specifically by inhibiting mTORC1. Interestingly, this is the same compound inhibited by other lifespan extension interventions, like caloric restriction, fasting, and maybe even intense exercise. This led to rapamycin being investigated as a lifespan extension drug in mice. Amazingly, rapamycin given to middle-aged mice led to a 5 to 16% increased overall life expectancy and a 28 to 38% longer life than their control group counterparts. The secret, it turns out, is in the dose. At high doses, rapamycin seems to have immunosuppressive and anti-tumor effects. At lower doses, it is a powerful longevity drug. It is difficult to study the effects of longevity drugs on human lifespan, given how long we live. But human studies have shown improvements to immune function, reduced cancer risk, reduced autoimmunity, and other benefits of low-dose rapamycin. More human trials are needed to determine if rapamycin can extend human lifespan, and fortunately, there is one currently underway at the University of California, Los Angeles, sponsored by a company called Ageless RX. So, is Easter Island home to the elusive fountain of youth? We'll just have to wait and find out. Until then, hit that like button and subscribe to Science Research Review.